Now we will take the second example for modal analysis. It is a free vibration of a rotor design. We need to perform a modal analysis for a rotor design. The model is fixed as shown in the figure. It is fixed in the center. And the material that is used for this rotor is polyethylene. Okay. So let us perform this analysis in Ansys Workbench. So now we will add another modal analysis system. Now, as described over there in the PPT, the material that we need to use over here is polyethylene. So I need to come to the materials and we need to add that polyethylene material. Once it is added, we can return to the project, come back to the project schematic window, and now again either create the geometry or you can import the geometry. Again, in this case, I will import the geometry. So I have this rotor design which we have created. Enter into the geometry tab. Set the unit system and generate the design. Now you can see that the model has been generated, but the entire model has not come. Okay, now this can happen because of the data loss. Now once the model has come, now we can observe over here that out of the 3 blades, only 1 blade has come. So now what we can do is, we can come to the pattern tool. You can use the circular pattern option to generate the pattern. So I'm going to select these faces. Okay, and the axis of revolution would be this axis. I need 2 more components which are evenly spaced, and we will generate. So now you can see that the blades have been generated. Now there's one more thing that I need to do. I need to generate a hole in the center. So I will select the XY plane and enter into the sketching tab. Once you come to the sketching tab, we will create a circle in the center. The diameter of this circle is 10 units. Once it is done, we will extrude it. And now I will say it has to be cut material and generate. So you can see that the hole has been created. Okay. Now one more thing we can observe over here is that it is a 3D model, but it is having uniform thickness. Because it is having uniform thickness and the thickness is small as compared to the other long dimensions, I can generate this model as a 2D model. Okay. So for generating the 2D model, I can come into the mid surface options. In this case, we will understand how to generate a mid surface using the automatic options. So first select one pair of the geometry. Now it says that it is out of the selection criteria, so we can give some selection criteria. I will say it has to be 3, and now give the faces. Okay, so selection tolerance, I will say it is 3. Now select the face, and then find face pairs. Now you can say yes. So now you can see all the faces have been selected automatically, and now we will say generate. So now we will see that the mid surface has been generated. Okay, so this is the model that we have generated. From the 3D body, we have generated the 2D body, and this 2D body we will be using for the model analysis. Once we are back to the project schematic window, enter into the mechanical window. this is our rotor design. Change the material, it has to be polyethylene. Also check the thickness, okay, and then we will generate the mesh. So we will use the default mesh settings. You will see that the curvature option is on. If you wish, you can also use the proximity and curvature to generate a much finer mesh. Okay, so you can see that at the connections at the joints, it has generated a much finer mesh. Okay, after this, now we will add the boundary conditions. So we will select the modal tab. Okay, before the boundary conditions, check the analysis settings. Now in this condition, I will say I want the first 10 vibrations. Okay. Now I will select the modal option. We will add a fixed support at this circle in the center, and then we will solve the analysis. Okay, there is only one condition, that is fixed support. Let us solve. So the software will start solving. After that, it will give me the results. So you can see the first frequency is at 160.6 Hertz. I can select all, right click, generate the mode shapes, and then we will right click and solve again so that we get the deformed shapes. So at 160.6 Hertz, the deformation is 630.18. Look at the animations over here. Okay. Okay, so you can see the vibrations. Okay. Now, if you try to add the stress, so whenever you add the stress, it will ask you at which mode. We have 10 modes over here. So at which mode do you want to add the stress? So I will say I want to add the stress, or I want to calculate the stress for the 6th mode. Okay. And now I will say solve. But here you will get one error or warning message for this. It will not solve because when you click on analysis settings, you have something called as output controls. So here we've already said that the stresses and strains are not going to be calculated. So if you wish to calculate this, you can switch on all these options, and then you can add the stress for the 6th mode, and then we can solve. Now you will see that the stresses has been calculated for the 6th mode, that is for this mode. So you can get the stress value. Similarly, you can add the stress value for every mode. Okay, but for that you need to make this change over here. So with that, we have understood how to perform a modal analysis on a model which was 3D in nature, but we have converted it to 2D because the thickness was uniform and it was very small. After that, we have performed the modal analysis of a rotor design.